Welcome, ladies and gentlemen. My name is Jeff McCullough with the U.S. Department of Energy's Pacific Northwest National Laboratory. I'd like to welcome you today to today's webcast entitled Using the Street and Parking Facility Lighting Retrofit Financial Analysis Tool. Sorry for the long wordage there. Brought to you by the U.S. Department of Energy's Better Buildings Alliance and the Federal Energy Management Program. With that, I'd like to make a few introductory comments, again offering my personal welcome to your attendance today. Here is the order of the day. As I mentioned earlier, this presentation is sponsored by the Better Buildings Alliance and the Federal Energy Management Program. Within those programs, DOE has initiatives underway to support, in this case, exterior lighting, and so we'll be sharing a little bit of detail on those here today for you. The main crux of today's presentation, of course, is the Street and Parking Facility Lighting Retrofit Analysis Tool, and we'll introduce our speaker here shortly. And then at the completion of Doug's presentation, we will go ahead and open up for questions and answers. Okay, so let me provide a few introductory comments and kind of kick things off today. Let me share with you the LEAP campaign, and the acronym stands for Lighting, Energy Efficiency, and Parking. It's a recognition and awards program offering resources, tools, technical assistance, etc., to facility owners and managers that are interested in highly efficient lighting in their parking and outdoor facilities. DOE provides tools and technical assistance to LEAP participants. And you'll see on this screen that we have some snapshots of what some of those tools are. I won't go through them in too much detail other than to say that there are case studies that can be used if you're interested in learning about the technologies and some of the applications. That's a valuable tool. There have been specifications developed that you can bring into your own construction documents or glean information from. We do offer a limited amount of technical assistance. So if you are a facility owner and you want a little bit of guidance as far as lighting layouts or technologies and that type of thing, we do offer some limited assistance there. There is measurement and verification guidance available. So if you're an entity that requires an M&V program, we have a resource available that shares what that looks like and how you might go about that. There is an opportunity for learning about utility incentives. In certain areas of the country, of course, utility companies offer rebates and incentives for efficient lighting, so there's a tool to help you locate those. There are specifications that are available for evaluating projects that you can also compare them, say, to the prevailing energy code in your location. We also offer webinars such as we're doing here today to further provide additional education. On the FEMP side, and FEMP, for those that aren't aware, is the Federal Energy Management Program. FEMP is currently running an exterior lighting initiative trying to move energy efficient lighting or more efficient lighting into the federal space. Clearly, with new technologies out there, specifically LEDs, there's great potential for energy savings, and depending on the application, they can be quite high, on the order of 50 to 70%, and when you say pair them with controls and various automation schemes. One of the things that FEMP has done to support this effort is to define FEMP designation or FEMP designated performance levels for 6 categories of exterior lighting. I should share with you that if you're a federal agency, you're required to follow, it's legislatively mandated that you use Energy Star in your selection criteria. Where Energy Star does not exist, FEMP steps in and defines performance levels. And so that has been done for you in the exterior lighting category. You can see the web address. It's long, but if you type in FEMP and exterior lighting, you can find it fairly easily in your browser. The upper right-hand corner are the FEMP designated efficiency levels for the 6 categories that I was referring to. By the way, these 6 categories cover about 98% of exterior lighting, so they are fairly encompassing. Another activity that FEMP has pursued is supporting federal agencies and departments in developing policies, essentially enabling them to use energy efficient lighting and kind of a de facto choice going forward. So if you're a federal agency, we've done some work with the Army and the Air Force. We're working with others. We'd also be happy to hear from you. If you are a federal agency and are interested in getting some assistance in that regard, we'd be happy to provide that for you. At this point, I would also offer federal sites are encouraged to join the LEAP campaign. And so you can see here the website for doing that. It's an opportunity to get recognition about your projects, to become more involved, to learn and gather resources, and that type of thing. Okay, at this point, I'm going to introduce our speaker today. And we're very happy to have as our speaker Doug Elliott of the Pacific Northwest National Laboratory as well. Doug is a senior research economist for the Pacific Northwest National Laboratory. Since joining the lab in 1991, he has participated in a variety of projects focused mainly in the areas of energy policy, resource efficiency, cost benefit and regulatory analysis, and software development. He received a BA in economics from Whitman College and an MA in economics from the University of Virginia. Doug, please begin.
Thank you very much, Jeff. Well, first off, I'm going to start off telling you a little bit about what this tool is and what it's not. The Retrofit Financial Analysis tool, as we typically refer to it, is an Excel-based analytical tool that may be used to evaluate the costs and benefits of conversions or upgrades to more efficient lighting technologies. And specifically, we're focused on street lighting and parking facility lighting, garages, structures, lots. But what it's not intended for is design assistance. It's not going to tell you what the optimal fixture is for a given location or application in terms of light output or light out quality. That's necessary to do that type of work before you get to the financial analysis stage. It's also not a database of various lighting technologies characteristics such as performance or cost. While many of those characteristics may be necessary as inputs to the tool, those are either up to the user to, well, basically they're up to the user to develop those inputs, in some cases with the help of links provided within the tool. Now, what kind of output can this tool provide? It provides a lot of the typical standard financial metrics that people are familiar with, such as net present value, which is arguably the most important one, internal rate of return, simple payback. It also provides a whole array of detailed annual cash flows broken out into various categories. Annual energy and energy cost savings, maintenance savings, and greenhouse gas reductions are also reported. Now, to be clear, we have this very long name now, but this is a new version of the tool we released in early 2012 as the MSSLC Retrofit Financial Analysis Tool. That version 1.0 was released in February of 2012, and then earlier this month we released 1.1 of the tool, which we renamed as Street and, well, I'm not going to even say the whole name, but basically we were trying to call attention to the addition of parking facilities to its abilities. But we'll probably generally just refer to it as the Retrofit Financial Analysis Tool. And yesterday we posted a new version with a couple of small tweaks, and so that's out available on the website now. Okay, how did this tool originally come about? This tool, the basis of this tool was originally developed by the Clinton Climate Initiative, CCI, a few years ago. And then with funding from FEMP and DOE's Municipal Solid State Street Lighting Consortium, we were able to take it to the next level and add a number of features and make it a little bit easier to use. Okay, what did we change in this version of the tool? As the name change indicates, the tool has been thoroughly vetted, so we understand and are confident in its applicability to parking facilities in addition to its original intended use for street lighting. As part of that process, we've made a number of improvements and additions. Partially in response to various user questions or confusion from using version 1.0, we've added a lot of usability improvements. Throughout the tool, we've added a number of clarifying comments, changes in language, formatting improvements that hopefully will make the tool simpler, more clear, easier to use. We've also Previously, we provided what we called a tips document. It was a few pages long, and now we've probably more than doubled the size of that. We've now referred to it as a guidance document. It's available as a PDF also on the website, and it's really, I really emphasize the importance of reading that prior to using the tool. There's a lot of really valuable information in there that could help avoid some confusion in use of the tool. Now, a couple of the more important features that were added in this version, we've added dimming capabilities. They're relatively simple, and we may expand the capabilities of that at a later time. But now, unlike in version 1.0, you can model at least simple dimming periods. And we've also, on the maintenance page, added the ability to estimate cost for up to 3 different controls. In the original version, only one control could be handled. And finally, in the original version of the tool, we hid the sort of behind-the-scenes calculation sheets, and we weren't trying to really hide anything from anybody other than we were worried that the tool was already complex and we wanted to try and avoid overwhelming people with the details. But nonetheless, obviously, some people are going to want to see those calculations, and so we've made those available now, but they are not editable, so you can't update or change the way the tool does its calculations, but they're fully visible if you'd like to get into the details of that. Okay, here's a quick overview of the structure of the tool. There are 4 main pages or sheets with which you'll interact. The input page, that's where almost all user inputs are entered. There's an optional maintenance page. You can enter maintenance cost on the input page, but if you have more detailed information or would like a more accurate estimate, you can go through the maintenance page if you desire. There's a results summary where virtually all of the outputs from charts to financial metrics to the cash flow data are reported. And then there's an optional finance page. If, as it very well may be the case, given the cost of some of the fixtures, debt instruments are going to be utilized, the finance page can help estimate the cash flows and the financial implications of utilizing those debt instruments. And then, as I mentioned on the previous slide, the calculation worksheets are visible now, but they're not user editable, so there's no particular need to go there, but you can look at them if you want to see what's going on with the calculations. There are also a couple of other sheets that I don't mention on this slide. There's an intro page that provides a basic overview of the tool, and a definitions page, which is basically a glossary. Okay, now I'm going to provide a little bit more detailed overview of each of those 4 sheets you're most likely to interact with. I'll first describe what the tool or what's on each sheet, and then I'll provide a visual overview of that sheet subsequent to describing it. The input page, as I mentioned before, contains virtually all the inputs you'll need to enter for the tool, unless you're going to utilize the optional finance and maintenance pages. There are 4 sections on the input page. There's what I call a global or project input section, and there you enter inputs that would impact all fixtures that you're going to analyze. Things like discount rate, electricity price, greenhouse gas emissions factor, overheads, installation and vehicle prices or rates. Those would be entered in that section. And then further below that section, there's what I call a technology-specific input section, and there are 2 parts of that section. This is where you enter fixture-specific data. In the item labeled 2 here on this slide, the section 1, there the user needs to enter fixtures or data for all fixtures or technologies potentially examined, both existing fixtures and new fixtures. And in this section, details about the fixtures such as wattages, operating hours, maintenance costs, fixture costs, rebates, things like that are entered. Further below that section is where the user specifies information for the impacted fixtures associated with this project only. And you select the fixtures to remove, the fixtures to replace, or the replacing fixtures, and then you specify the quantities. And finally, there's what I call a user notes and scratchpad area. Given that only the input cells are editable in the spreadsheet, we wanted to have some place where the user could record notes or do some calculations. And so there's a large editable area. In fact, I'll just go to the next slide and show that now. The user notes and scratchpad section is section 4, is highlighted in this slide here. And to go back and describe these other sections, the global project level inputs are in section 1. Section 2 is the fixture-specific inputs, where you enter data like wattages for all fixtures examined. And then section 3 is where you enter which fixtures are going to be removed, which are the replacing fixtures, and how many. Okay, on to the maintenance page. As I mentioned, on the input page, you may enter maintenance costs directly there on a $1 per unit per month basis for each fixture. But if you have more detailed information, or if you don't know those costs, the maintenance page can help you derive very detailed estimates of those costs. And it captures all costs associated with maintenance, whether it be labor, vehicles, equipment costs. And I should note here that vehicle is very broadly defined in this tool. It could involve a scissor lift or any other equipment that might be necessary for installation of the fixture. There's a scheduled maintenance section on the maintenance page. This is where you typically handle scheduled group relamping. In this section, you can handle lamp costs, control costs, fixture costs, and then cleaning costs. And the unplanned maintenance section is basically a parallel of that, other than it doesn't have cleaning. I think, correctly presume you wouldn't do any unplanned cleaning. Okay, and here's a visual overview of the maintenance page. You can see section 1 there. That provides some optional user overrides. By default, the tool will use the labor and vehicle and fixture costs that the user entered on the input page. But if, say, maintenance was contracted out to a third-party contractor, then it might be necessary or valuable to enter specific labor, vehicle, and or fixture costs on the maintenance page just for use with the maintenance. And then section 2 there is the scheduled maintenance, and section 3 is the unplanned maintenance section. Okay, on to the results summary. There are 3 sections to this sheet. There's a summary statistics section where you get the various financial metrics such as net present value and internal rate of return. And there's also a series of cells that report what I call the full implementation reductions of energy use, energy cost, and greenhouse gases. And by full implementation, I mean when the project's fully completed. In the case of street lighting, it might be 3 or 4 years until the project's completed if a municipality or other entity has many thousands of fixtures. In the case of a single parking garage, it's much more likely that full implementation would just mean 1 year. And then also on the results summary sheet, 15 years of very detailed cash flow data are provided. And there are also a series of charts that help visualize these outputs. And here on this slide, you can see the various sections. Section 1 there is the section that provides the various financial metrics. Section 2 is the wide array of cash flow data. And section 3 provides the charts. Okay, on to the finance page. Now the results summary is reporting results as if no debt instruments were used, but in many cases that may not be realistic, and the user may want to visit the finance page to see what the financial impact is of employing various debt instruments. And this sheet allows the user to specify up to 8 loans, and each of those loans can have unique amounts, terms, interest rates, can start and stop years. And then after entering that data, you can go further down on this sheet and look at various financial summary statistics such as net present value and internal rate of return and compare the values both with debt and without debt and see how they've changed. And then finally on this sheet, there's quite a bit of detailed cash flow data on an annual basis. So here's the visual overview of this finance page. On section 1 is where a user would enter or specify various loans that to be examined. Oh, and I should have mentioned earlier, any of the peach-colored cells, those are input cells. and anything not peach-colored is non-editable by the user. Section 2 on this sheet is where the summary financial metrics, both with and without debt, are provided. Then Section 3, which actually extends quite a ways further down, as the arrow indicates, is where the cash flow data is provided. Okay, now I'm going to step through a couple of examples here. These particular examples, they're nominally street lighting examples, but in reality, the semantics, the naming of the fixtures, the costs or other data that I've entered here, we could change the variables, change the names, and it wouldn't be any different for parking facility or parking lot analysis. It would work exactly the same way. Okay, in this particular example, we're going to assume we have a municipality with 41,000 streetlights, and they own the streetlights, and they're interested in looking at retrofitting their high-pressure sodium fixtures with LED fixtures. And this municipality purchased replacement fixtures at a per unit cost, and they're going to use their own internal resources, both labor and vehicles, to install the fixtures at an hourly rate. And they have a maintenance program using internal resources, and they undertake group relamping on a planned basis. Okay, and a few key variables that I'm going to highlight in this particular example. We're going to assume an installation vehicle rate of $150 an hour and an installation labor rate for the crew of $400 an hour. And we're going to also assume that it's going to take them 16 minutes to install each fixture. And again, I really want to emphasize here, these data are for example only. They aren't necessarily valid data that anyone should go out and use. I was trying to create an example to show how the tool might be used. Okay, here's the project level or global level input section of the input page. So you can see I've entered data for a wide variety of variables such as sales tax, electricity prices, and in the green circle there I've highlighted the installation vehicle rate of $150 an hour and the installation labor rate of $400 an hour that I highlighted on the previous slide. Now we're going to go down to the technology-specific input section where we enter fixture-level data such as wattages and output levels, operating hours. This slide, I'm not highlighting any specific data, but all this data would need to be populated. And you can see here we've got the two high-pressure sodium fixtures, 100 watt and 150 watts. Those are existing fixtures, and we're going to examine replacing those potentially with 70 watt LED and a 68 watt LED fixture. Now this slide shows effectively scrolling further to the right in that section of the technology specific input section. And here in the first green oval there, I highlight that I've entered 16 minutes, which was the assumed install time mentioned in the earlier slide. Now in the second green circle over here, I wanted to call attention to the fact that you can enter, there's a drop-down list available in these cells within that circle where you can specify user entered or maintenance page. In this case, on this slide, I've specified user entered and entered $6 per unit per month for the high-pressure sodium fixtures and $1 per unit per month for the LED fixtures. But in this case, we actually want to utilize the optional maintenance page. So on this slide, I've changed that drop-down selection to maintenance page. And then you can see in the second green oval on this sheet that costs from the maintenance kit page are being pulled in there, estimating the dollar per unit per month cost of these maintaining these fixtures, $5.39 for the HPS fixtures and 77 cents for the LED fixtures. Okay, this is further down on the input page where we specify which fixtures we're going to remove and which are going to be the replacing fixtures and how many. You can see we're removing both of the HPS units, and we're going to look at replacing both of those with the 70 watt LED, and just under 40,000 of the 100 watt HPS are going to be removed, and 1,000 of the roughly of the 150 watt units will be removed. One thing I wanted to call attention to is the tool is designed for one-for-one retrofits only. It doesn't take into account or provide the ability to look at changes in, say, pole spacing or number of fixtures per pole. So that's the default way the tool operates. That said, there are potentially ways to work around this by, say you had additional mounting brackets that you needed or something of that nature you needed to add additional fixtures per pole or if it was in a parking structure, per installed spot there. All of those additional costs could be incorporated into the fixture cost cell on the input page. So in short, I want to say there are workarounds for some of these simplifications that we've made. Okay, on to the maintenance page. This is the user override section of the maintenance page where the user can decide if they want to use the installation and labor and fixture costs entered on the input page, or if they want to enter a unique cost for maintenance costs. For example, if they had a third party handling the maintenance. But in this case, this municipality using the same labor and vehicle resources for original installation as they are for maintenance. So in the green oval there, you can see that I've chosen input page for the vehicle and labor rates. Okay, here's the scheduled maintenance section. Not going to say too much about this. I've entered a series of costs for this. One thing I did want to highlight for lamp rated life, if you're going to undertake group relamping, rather than entering the actual rated life of lamps there, you should enter the time until the scheduled group relamping. And here's the unplanned maintenance section here, where given that this municipality undertakes group relamping, the costs in this section are going to be relatively minimal. But this section still handles the unanticipated, relatively rare, but still occurring early failures of devices. Okay, on to the results summary here. As you can see in the highlighted oval there, the simple payback of this example was 6 years, and the net present value was just under $21 million. And then in the section below that I've highlighted with the green arrow, the savings and what I previously had mentioned, I refer to as the new baseline values, or time of full implementation values, are reported in that section below. And you can see that on an annual basis, the municipality is going to save about $850,000 in terms of energy costs and avoid the emissions of about just under 7,300 metric tons of CO2 equivalent. Okay, and here's a couple of examples of the charts that are provided. You can see in the first chart here that the LED fixtures knock the energy use down by roughly 50% as compared to the HPS fixtures. And in this second chart, the annual cash flow with components chart, you can see the impacts of the capital costs in the first 4 years. The city took 4 years to implement this street lighting project. So the deep negative blue bars for the first 4 years in that chart represent the capital costs, and subsequently you see that there are only positive cash flows. And in this particular example, the O&M costs actually largely outweigh the energy costs, and that's not necessarily surprising with LED fixtures given their long fixture lives. Okay, on to the finance page. This isn't a cheap project, so for this particular example, I've entered data for 4 loans, basically coinciding with every year of the implementation period. As I mentioned, this project was implemented over 4 years, and I've entered in the green oval section there loans that covered the capital cost for each of those years. But the user may enter any values they want there for interest rate, term, start year. It's very flexible. Okay, so what are the impacts of those loans? The summary statistics page further down on the finance page reports some of the metrics provided earlier on the results summary page, but now we can look at it both with debt and without debt. You can see that the NPV of the project fell from just under $21 million to about $17.2 million as a result of the cost associated with debt service. Okay, now I'm going to look at a slightly different example that looks at a little bit different way of using the tool. This is largely going to be the same as scenario one, except for in this case, the municipality decides to use a third party to install the original fixtures. And that third party provides a bid at a fixed per unit cost to install each fixture. The city's going to still maintain the fixtures with their own labor resources. Okay, so how do we derive this labor rate? We receive a bid of $119.17 per fixture to install them, and we learn that the crew can install 6 fixtures per hour. So if we multiply $119.17 by 6, that yields an effective labor rate of $715 an hour. Now, so how's this going to impact our input variables? Well, originally we had separate vehicle rate and labor rate values that we'd entered in scenario one's example. But it doesn't really matter to us where we enter the costs as long as we capture them all. And given that the labor and vehicle costs in this example aren't separable, I went ahead and entered the full $715 an hour in the labor rate cell and entered 0 for the vehicle rate. Oh, and one other key variable here, since I can install 6 fixtures per hour, we've got a per fixture installation time of 10 minutes. And so basically what we've got here is we've got a higher combined labor and vehicle rate, but these crews are a little faster, so we've got a reduced installation time, and we'll see if this ends up being on a net present value basis a better option for the municipality. Okay, here's a look at the input page. You can see in the green oval there, I've deleted the previously entered vehicle rate, and I have changed the labor rate from $400 an hour to $715 an hour. Now on to the technology-specific input section. On this slide, you can see in the first, on the left there, the first green oval, I've changed the install time from 16 minutes to 10 minutes. But then in the second green oval there, you note the maintenance costs there. And I recall that the maintenance costs in the original example were somewhere around $5.50 per unit per month and 77 cents for the LEDs. But yet they've gone up here. So we need to revisit the maintenance cost page to see what's going on here. Okay, now we're on the maintenance page here. This is the user override section of the maintenance page. And the key here that was driving those maintenance costs increasing is that originally we'd entered in the first example, we'd specified that the maintenance page use the labor and vehicle rates input on the maintenance page. But now those have changed, and that drove up the increase of cost. Yet in scenario 2 example, the municipality is still going to use their own labor and vehicle resources to maintain these fixtures. So we want to enter overrides here. So you can see in that large green oval, I've changed the vehicle rate and labor rate from input page to user entered, and I've specified $150 an hour for the maintenance vehicle rate and $400 an hour for the labor vehicle rate. And as you can see in the smaller green oval at the bottom of the slide, the maintenance costs have fallen back down to the levels we had before in scenario 1, $5.39 per unit per month and 77 cents per unit per month. Okay, so on to the results summary here. How did this impact the results using this third-party crew? Well, as it turns out, the simple payback is actually slightly better. Originally, we had six years simple payback, and now it's fallen to 5.7. The NPV originally was roughly 21 million, and now it's roughly 22 million. And the capital expenditures fell somewhat. And here are the scenario 1 results. You can see over on the right on the cash flow that the annual capital expenditures fell by roughly $300,000 a year under scenario 2. And here's the cash flow chart associated with scenario 2, and here's the one associated with scenario 1. And the only difference is the greater upfront capital cost associated with scenario 1, as you can see in the chart there. Okay, I wanted to make a few more comments on inputs. As I mentioned before, although that was nominally a street lighting example, the tool works exactly the same way for parking facilities, lots and garages. There are a couple minor differences from inputs in that, as I mentioned before, I believe unless we're dealing with a whole portfolio of parking structures, if we were looking just a single or a couple parking structures, it's likely that that project would be implemented in just 1 year. And so the last year of implementation entered on the input page would probably be 1 rather than 4, as in our street lighting example. And one nice side benefit of projects implemented in a single year is that it's not necessary to enter cost escalators for labor, vehicle, and fixture costs. Those escalators only apply to installation cost, and if you're installing them all in 1 year, there's no concern about cost escalation for future years then. And I believe I mentioned this before as well, but I also want to mention again that vehicle really is defined broadly in the tool. So if you see the term vehicle, any equipment necessary to install a fixture can be, the cost may be placed in this category. And scissor lifts is a prime example that might be used in a parking structure. And one more thing, as I mentioned before, the tool is by default set to analyze 1-for-1 fixture retrofits. And I did mention that there may be ways to work around that by utilizing the fixture cost field on the input page. Okay, now where do you get the tool? For those of you that haven't downloaded the tool before, it's still hosted on the same site. It's hosted on an MSSLC web page. And on that site, you'll find a zip file that includes 2 versions of the tool, has 2 Excel files within it, one with sample data and one without sample data. And again, these sample data are not to be considered defaults in any way. They are just purely to provide an example of how the tool is to be used. And also on that web page are some additional documents that should be helpful in learning how to use the tool. There's a guidance document, which I think is really important to read, and there's a release notes document that lays out the various changes we've made in versions of the tool release since our initial early 2012 release. And there are some links to various presentation and webinar materials that we've produced in the past, and sometime in the near future, materials from this webinar will be posted there as well. And we also have an email address that you can use to send any questions about the tool. It's msslc@seattle.gov. And then down below in these latter bullets are some additional related links that many of you may find of interest. The Lighting Energy Efficiency and Parking, or LEAP campaign, can be reached at the link in that bullet. And we also provide links here for federal efficiency requirements for exterior lighting, and then the main page for the MSSLC. Well, thank you very much, and I think we're going to switch over to Q&A now.
Thank you, Doug. Appreciate that presentation today. We've received a number of questions throughout the presentation, and so we'll answer those the best that we can. I will forewarn you that there are certainly more questions than we can answer. There are some that are more specific, meaning folks that have interest in financing opportunities or rebates and incentives in their service territories, and so we're really not in a position to answer those kinds of things. So I'll parse the questions a little bit, between Doug and myself. We also have Bruce Kinsey, who manages the Municipal Solid State Street Lighting Consortium. And so what I'll do is I'll go through some questions, and I'll either direct them to Doug, or I'll answer them myself, or perhaps send them to Bruce. So let's go ahead and get started. We have about 15 minutes worth of time that we can go ahead and dedicate to this. And the first question, and this one is for Doug. I have version 1.1, which says last updated 7/31 of 2013. Is this the latest version?
No, that's actually not the latest version. Yesterday, we posted version 1.1.01. As the number might indicate, it's a very minor change. So you could go out to the MSSLC website and get that new version right now. It was available as of roughly the middle of the day yesterday.
Super. Thank you. Thank you. The next question, and this actually has occurred, or I should say several folks have asked this. This is an excellent tool for outdoor applications. And so obviously it's been focused on outdoor parking and parking lot, parking structure. And I think I know the answer, but I'll turn it to Doug here to kind of answer it maybe in more detail. But can it be used for interior fixtures? If not, is there a tool or similar tool for interior applications? And I know the answer is no, this can't be used for interior. But Doug, do you have any thoughts as far as other tools that might be used, or any other knowledge there?
Off the top of my head, I don't know of any other tools that might be used for interior fixtures.
Yeah.
I'm afraid I don't know the answer to that. Although I agree though that the tool is not applicable to indoor lighting.
Yeah.
Our tool.
One of the challenges that I would make the attendees aware of is that there's when we start talking transitioning from one technology to another. So for example, if I have a high intensity discharge type light source, and of course solid state lighting or LEDs are kind of fast up and coming, and there's a lot of interest in them. One of the challenges is, can you say that there's a direct one-for-one comparison? So for example, if I have a 150 watt, say metal halide, is there an equivalent wattage of LED? And it's a sticky path to think about it that way, because one of the things to consider here is providing the correct amount of light for the task or the application. In this case, LEDs have an opportunity to improve not only the color spectrum, but also to improve the uniformity. And so looking at raw light output and trying to compare across technologies is a challenge. So I say that from the standpoint that we need to be careful that you're providing the correct amount of light for the task or the application. And there really isn't a good hard pat rule of thumb that if I'm using 150 watt metal halide, then I need 70 watt LED. That kind of gets you down the right path, but it does require analysis, and it also assumes that you're maintaining the same light levels, same light striking that surface. So enough of that. One of the attendees asked, and I'll answer this one, Doug. How is the luminaire efficiency rating determined? And actually, it's luminaire efficacy rating. This is important to understand that incumbent technologies that use a ballast are also measured in a different way. They're measured with what we'll call relative photometry. I won't spend too much detail on that, whereas LEDs use absolute photometry. So very quickly, for a product that uses a ballast, the way that you calculate LER, or luminaire efficacy rating, is the luminaire efficiency. So this would come from a photometric report. The total lamp lumens, so the nominal lumens from the lamp sources, times a ballast factor, and that again depends on the technology, divided by the input wattage. So that number gives you a luminaire efficacy rating. Now if I contrast that with, say, an LED product, we actually use straight luminaire efficacy. Because it's measured in an absolute fashion, you put the entire luminaire in the measuring device, the apparatus, and it gives you total light output divided by power input. So they can be used for comparative purposes, but how they're calculated is different. Okay, let's go ahead and move on to the next question, and this one is for Doug. And the question, Doug, is why are ballast costs not included in maintenance for high-pressure sodium and metal halide fixtures?
Bruce, do you want to help me on that one?
I'm sorry, Jeff, can you repeat the question?
Yeah, I'll repeat the question. Why are ballast costs not included in maintenance for high-pressure sodium or metal halide fixtures?
I think the ballast costs are just, we assume that they're rolled up as part of a sort of a single maintenance somebody has looked at. Rather than breaking down all the different components, someone has just rolled those up and includes those as part of sort of an overall monthly or whatever the unit is maintenance cost. Isn't that correct?
Well, we do have, on the detailed maintenance page, we do have lamp cost, fixture cost, control cost, cleaning cost, but we don't have a separate ballast category. So other than having it be part of the fixture costs, I'd have to think about that further.
Okay.
I guess.
Okay. Thank you. Thank you. Let's go ahead and try and get to a few more questions. And this one is also for Doug. And Doug, if you need to punt on this, you're welcome to. Only from the standpoint that I don't know if there's a quick and easy answer for it. But let me go ahead and read this to you. I know it impacts, obviously some of the folks that are municipalities. So the question reads: many municipalities are not billed for their streetlights based directly on a constant usage rate. Does the tool allow for analysis relevant to municipalities that do not own their lights and/or are charged a flat rate for poles as opposed to by their metered usage? For instance, is there space for inputs of two different flat pole rate tariffs for high-pressure sodium and LED as opposed to metered use?
No, there's not a space to input that, but there is likely a way to work around that. Essentially embedded in those flat rate per pole tariffs are energy costs, and those should be able to be obtained from the utility. In fact, we've got a section in our guidance document that discusses this very question. So I believe that by contacting the utility, although for example, if you went from high pressure sodium to LED fixtures, the per pole tariff would change, but the embedded energy cost would not change generally in that case. And so it'd be possible to extract that and enter the associated energy cost into the tool, and I believe then the modeling would work just fine. But I recommend checking what we've written in the guidance document.
Doug, this is Bruce again. Also, that's one of the reasons we have the two options for maintenance. Either you can calculate the maintenance, or you can just enter, if you're leasing the luminaires and getting a monthly maintenance tariff, which is pretty common, you can just enter the corresponding amount as your user entered value.
Okay.
Thanks, Bruce.
Good. Thanks for that addition. Let's ask another question as far as inputs. A couple of the attendees have asked how energy rebates are actually input into the document. Is that something you can do, Doug, pretty easily, and maybe even back up on your slides? I don't know how best to convey that.
Let's see here. Just back up to, here we go. On this slide, you can see there's a rebate value, and these rebates by default are tied to the installing the replacement fixture. And while that sometimes may be the case, that if you install a 70-watt LED, for example, on this screen here, you see there was an $82.75 rebate, but maybe that rebate is dependent on the energy savings provided, so it would be dependent perhaps on what fixture is being replaced by that LED. And in that case, there's a workaround here. in that one could enter this LED 70 watt fixture twice in this row and specify a rebate specific to replacement of the 100 watt fixture, HPS fixture, and another rebate to associated with replacing the 150 watt fixture. Let me back up one. Let's see here if I have I may not have an image of this, but I'm afraid. But there's an additional input cell in that section of the input page that a user can add an additional description to the fixture name, and so you could differentiate then those LED 70 watt fixtures to LED 70 watt replacing HPS 150 or replacing HPS 100 watt. So that would be a way to work around the case where your rebate is dependent on the energy savings rather than just a flat rebate for a given LED fixture, for example. Hopefully I answered the question there.
Mm-hmm. Okay, thank you. I'd like to circle back to one of the earlier questions, and that was one of the attendees asked about a location for finding incentives within their service territories and that type of thing. It's been brought to my attention that on the LEAP campaign, there is a tab, and so I recognize you don't have the website up, but if you go to the LEAP campaign, there's a tools page, and within that there's a number of utility incentives for parking lot and parking structure that you can utilize. I don't know if it's all encompassing, meaning if it is all the possible rebates and incentives that are out there, but we have tried to identify those to the extent possible. So feel free to go out to the LEAP campaign website and see if there's some incentives out there that might help you. Okay, let's get on to a couple more questions. One of the things, and I touched on it a little bit earlier, but actually before I do that, let me answer or bring up another question for Doug. And the attendees want to know, is the ballast wattage, so for an HID type product, is the ballast wattage accounted for? And then what he's really asking is, if we have a nominal lamp wattage of say 100 or 150 watts, obviously the ballast draws additional energy. I believe the answer is yes, but Doug, do you want to kind of talk about that a little bit more?
Yes, I'm seeing if I have a slide. Oh, there we go. On this slide here, you can see under the power and demand and dimming section that there's a lamp watts and a system watts. And in the case of the HPS 100 watt fixture, we've got 142 watts entered for system watts and 104 lamp watts. So the ballast is accounted for via the system watts column.
Okay, good. Thank you. Thank you. Let's see. We have about 3 or 4 minutes left, so let's try and get a couple more questions in. And this is another question for Doug, and it has to do with the maintenance on LED light fixtures. And Doug, the question is, why do we have a cost for maintenance for LED fixtures? And I think what they're asking, of course, is LEDs, when we measure them as far as what is their useful life or what is their rated life, they are fundamentally different compared to our incumbent technologies, meaning the lamps don't fail, the LEDs don't fail catastrophically. They literally get dimmer and dimmer over time. The industry defines the point at which 70% of the initial illuminance or luminance is maintained. And so when you compare that with an incumbent technology where a lamp actually burns out after a specific period of time, you have to kind of take that into account. And so again, Doug, I was kind of queuing up a question for you. So in the tool, why do we have a cost for maintenance for the LED fixtures?
Well, although there's very likely very little to no scheduled maintenance, there's still the possibility of the rare failures of a fixture that would require spot replacement. And additionally, there also may be minor rare scheduled maintenance for cleaning the fixture. But as the examples showed, or in my 2 examples, the maintenance costs associated with the LEDs were there were dramatic maintenance savings associated with going from HPS to LED, and in fact, that provided most more financial savings than the energy savings. So the person that asked the question certainly right. The maintenance is quite low with an LED, but there still may be some unexpected maintenance or some cleaning required.
Mm-hmm. Okay. I'd like to, some more of the attendees have kind of circled back to the utility incentives issue. And so for federal as well as for private sector type of entities, there is a website that is very good for finding incentives. And I'll give it to you, and if you want to write it down really quick, you can. But it's a Desire website, but it's www.DSIRE, so Desire USA, so all one word, DISIREUSA.org is a site that you can use for finding incentives. Okay. One of the questions that has come back, and I'll do this again very quickly, one of the attendees just recently asked for additional discussion on calculating LER, or luminaire efficacy rating, for an HID product versus luminaire efficacy. And so once again, for an incumbent technology, and it all stems from how the products are measured, but it's the luminaire efficiency, and just think of that as the fixture efficiency, the amount of light that actually leaves the fixture, times the total or the nominal lamp lumen. So if you've got one lamp, it has a nominal light output from that lamp. If you've got multiple lamps, you would enter that in there. Times a ballast factor, and it is possible for some technologies to underdrive or overdrive a light source, so that's why the ballast factor is important. And you divide those three by the input wattage, or the luminaire watt input. For LEDs, it's measured as is, meaning the entire luminaire is tested, and so the net light output divided by the power input is the result. So incumbent technologies use LER, solid state or LED uses luminaire efficacy, but they can be compared to each other. So if you're going from one technology to another, the number essentially is net light output divided by power input. Okay, with that said, we are on top of the hour. I think I'm going to go ahead and call the ball at this point, and let me offer our thanks for your participation today. I know that the slides will be made available. I know that's something that's asked frequently and often, so the slides clearly will be made available. And with that said, thank you again for your participation in today's webcast, brought to you by the U.S. Department of Energy. You may all disconnect. Have a great day.